CBT Nuggets JNCIS Security Series SRX Interface and Zone Basics. Funny story, several years ago, quite a few years ago actually, when I started teaching Cisco security and their CCNA security track, Cisco talked about their zone-based policy firewall, and in classic Cisco fashion, we were representing the topic as if Cisco had thought it up and it was their own new paradigm. Well, the truth of the matter is, zone-based firewalls have been around for quite a while, and Cisco kind of came to the table late on that one. Juniper had already been there. The SRX had already been there. And this zone-based firewall is the standard in the SRX and even on the Juniper J-series routers. So in this nugget, we're going to get in and talk about some of those zone basics, the fundamentals of zone-based firewalls, also interface basics, because that's what it's really all about. That's where all the action happens. And so we'll start off with a little bit of background and kind of look at where we came from, and then we'll get in and build a foundation on some of these very important concepts. Okay, well, to understand where we're going to, it might help to find out where we've come from, okay? The traditional classic firewall was usually a two-armed or a three-armed firewall. Now, what did we really do? Well, we would assign an interface and say, you're going to be on the inside corporate network, okay? You're the trusted interface. Then you have the outside, which was the untrusted interface. And this would connect, to maybe some customer edge router, maybe even directly to your service provider through some DSL or cable connection. And of course, back in the day, this could be things like frame relay, things like that. Then we had our inside network, was really our pool of corporate users. And this, of course, would be reached through some layer 2, layer 3 switch, some router right here. So this is our pool of internal users. And on the two-armed firewall at a branch office, for example, usually we have almost all of our traffic being initiated from the inside, going out here and getting access to servers on the internet, web servers, FTP servers, other application servers. There's very rarely any traffic that's sourced out here on the untrusted internet going into the inside. If there are, on a case-by-case basis, we have to modify the rules. Now, what do I mean by rules? Well, that's what we used. We used access control list or access control rules, and we applied a bunch of statements or entries of these rules on lists, access control list, and we applied them to the interface in a certain direction. Okay? Inbound, for example, was the most common. And then we also started doing what was called application inspection and control, which was layer 5 through 7 of the OSI model, session, presentation, application, for more sophisticated applications and services. And so what we would use was some kind of context-based access control, where based on the context, for example, using random ports or grabbing ephemeral ports, we could make modifications. And we would use a list of commands, by the way, to inspect the traffic, okay? Inspect the traffic that's being initiated on this interface and inspect the traffic that's coming back on this interface. The challenge with that is twofold. Number one, we have to manage a lot of lists. Context list, access control list, and secondly, they're being applied to the interface. So it wasn't very scalable, it was very complex, and it wasn't flexible enough for us. So that's a two-armed firewall at a branch office. Now, the three-armed firewall simply meant, look, we don't want to have any servers on the inside hosting services for users on the outside. We don't have to open up a hole like we did in our two-armed firewall to give users out here on the wild, wild internet access to a server here. Okay, that's too dangerous. So we'll stick all of our servers out here in a zone called the DMZ. Okay, so all of our public-facing servers, all the servers that are responding to requests from the internet, and this could be, business partners, extranet partners, vendors, large customers, whatever, okay, of this branch office. It could even be other branch offices. We want to make these servers available to them, but we want to put them out here in their own DMZ zone. And the same thing applies. Every time you add an arm to the firewall, it's more access control lists and more context lists you have to deal with. And now we have to think about traffic, that's sourcing out here on the dangerous internet. We also have to think about, is there anything being sourced on these servers here. It's not very common, but we have to think about it. And then what about the traffic between the inside and this zone? If you open up holes in your firewall for traffic to flow between these two interfaces, the DMZ interface and the inside interface, that's also other vulnerabilities to be aware of. Something else has happened as well. This 3-arm firewall for the branch office is actually starting to have more arms. Why? Why do we need more arms in our firewall? Well, what about voice over IP traffic? What if you have a wireless local area network for your guest users at that branch office? Or a guest VLAN, we could call it. What about a management VLAN? If it starts to get big enough, do you want to segregate your management traffic? So we take these branch firewalls and now we're creating more arms, okay? Or more interfaces that are connected to different domains, security domains. And that just simply means a lot more rules and a lot more context lists to add to interfaces, inbound and outbound, protecting traffic between all those different domains. So what Juniper does is it takes a whole new novel approach to this. And it wasn't their idea, frankly. Juniper got it from the Screen OS and the NetScreen, kind of the predecessor to the SRX, and they've used a zone-based policy now. Well, now, instead of applying all these rules or lists to an individual interface, we basically create a zone and we apply the policy to the zone, and then we associate the interface or interfaces with that zone, and it subsequently will receive that policy, that security policy, based on its zone membership or its zone assignment. And that'll become clear as we move through. But before we start configuring, and I know you're already just kind of anxious to jump on and start configuring this, we need to understand a little bit more about zones and security policy and the way traffic flows through our SRX. And we'll also look at what's kind of the default. What is the factory default configuration on our SRX? Got to know that for sure. Let's say you're working in the healthcare or the medical industry, and this is the corporate office. We could call this the headquarters of our medical center or our hospital, and you work in a remote office, branch office, which is actually a lab, okay? And a lab that we'll call affectionately Nugget Labs. Why not? Okay? And it's your responsibility to implement your SRX device here and then provide ongoing operational security for a wide variety of services that the SRX provides. So the first thing you have to think about is what zones are you going to have, okay? And so typically, this is actually a Juniper diagram. You're not going to be dealing at this level in the JNCIS security with this SRX device that you would see here, or stack of devices at the headquarters, okay? That's going to come later. You're responsible for this device. You're going to have two zones. You'll have the trust zone, which is the internal corporate zone, and the untrust zone. And what's important is, I talked earlier about how, yes, you can have other zones set up on this SRX. For example, a DMZ zone with public servers and other zones for other special cases. But the first thing you have to do out of the box is make sure that you have these two zones set up. Because initially, what you're really concerned about are all of the hosts behind this device at the remote office branch office being able to access corporate resources through this SRX from the trust zone to the untrusted zone. That's your first responsibility, and to protect all of these devices in the trust zone from a wide variety of attacks and vulnerabilities, okay, with a defense in depth strategy on this SRX. So it's really two zones initially we're concerned about. Now, by default, the SRX comes pre-configured with 3 security zones. Okay, we already know what 2 of them are. Okay, the trust zone and the untrust zone. There is a third default zone that we'll talk about. Okay, it's called the Junos Global Zone. Now, since the SRX is a zone-based firewall, all the security policies that we're going to create are associated with zones, and then interfaces get attached to zones. Now, the SRX device is also a layer 3 device, right? So it has to perform some routing capabilities because it has to route between the security zones, right? It has to do a route lookup to figure out the destination zone context before it can apply the correct policy. As a matter of fact, before our SRX can do a security policy evaluation for any traffic flow or a session, for example, it has to do 3 things. and this is important for the exam. One is a screen check. We'll talk more about that later. The second is a route lookup. And the third is a route lookup to determine the destination security zone. Now, okay, is this all the processing that is done by our SRX on a traffic flow? No. As a matter of fact, as painful as it might be, we've definitely got to look at how our SRX evaluates a packet flow. And I put together a diagram based on a Juniper diagram. It's my own time-consuming, elaborate kind of workflow process, but we need to go through it. Even though there's some concepts that are beyond our knowledge at this point, you'll want to come back to this diagram definitely before you take your exam and definitely before you go on the job. Let's check it out. Okay, now I realize this looks a little bit intimidating, but don't let it freak you out, because obviously we don't have to memorize all of this, but this is important medicine that we have to take because we will feel better in the long run, all right? So what is this? Well, this blue box here, this is our appliance. It's our SRX, right? And so this is an ingress packet, so it means it's going inbound. And let's say this interface right here happens to be the interface that connects to the untrust zone. Okay, so in other words, it connects to our service provider. This is the interface that connects to the trust zone. Okay, so it is our inside corporate hosts at the branch office, right? So the packet's coming ingress, so it's coming from the service provider, and it's going to ultimately be coming out this interface, egress, outbound, to one of our hosts. Okay, PC, laptop, whatever. The first question that when the packet comes in to the interface is, does it match an existing session? So is this part of traffic that probably already was initiated from one of the hosts on the inside? For example, they're trying to get some web page from a web server, and the web server is finally returning that web page to them. Okay, so it's coming back. Is it part of an existing session? Well, this is an interesting concept because your SRX uses what routers have used for years traditionally, and that's called fast cache. Okay, in other words, if this is already part of a session, it just skips a bunch of stuff, a bunch of processing, and goes right to this fast path. Okay, let me give you an example. Whenever I take my kids to an amusement park like Disneyland or Disney World or Six Flags, you can get these flash passes right before you go on a ride. You can pay extra money. It's either a ticket-based system or it's some kind of little box that you get, and you actually get you pay quite a bit for it, but you get to kind of go to the head of the line and not wait for an hour and a half or 2 hours to go on some great roller coaster. Okay, that's kind of the way this works. Not a perfect analogy, but you get the idea. We get to skip part of the line and go right to the flash pass line, right? Okay, well, let's say that it didn't match an existing session. Okay, so it goes to the first path because this is the first packet of the session. And by the way, if it doesn't match an existing session and it's coming from the outside, that means ultimately we've got some server on this trusted interface down here that's servicing the outside, which is a scary thing altogether. So it does a screen check, and again, we're going to talk about these things a little bit later on. I want to focus on just one thing here, but it does a screen check, basically looking at the firewall rules, okay, the ACLs. It then wants to know if there's any network address translation that has to be done, because that's important, because before the route lookup can be done, we have to make sure that we translate the address from some public routable address, some global address like 209.165.200.3 to something that's being translated to an RFC 1918 address like 192.168.1.10. Okay, so we have to do that translation because the route table is going to have the original address in it. Okay, so then we do a route lookup, and of course it goes to a forwarding lookup. It can loop over there, and this is the big thing, the firewall policy lookup. That's what we're talking about here. That's our security policy. So that security policy is applied at this particular point, right after the route lookup, and it looks at a forwarding table. So we're going to know what interface, which by the way is associated to a zone, we're going to ultimately send this packet to. Okay, we have to know that. Why? So we can know what policy to apply, right? That's why I said earlier, after the screen check and the route lookup, you do another route lookup, a forwarding lookup, to determine the destination security zone, right? So we have to know that. And then, of course, there can be some more translation, some upper layer inspection, application layer gateway, maybe some intrusion detection, VPN services, okay? Once you get through all of that, now we install the session into memory, okay? And then we kind of come back over here and we can start moving into these processes. Now, like I said, if it's already an existing session, it just skips all this and goes right to a firewall screen check, a TCP check, routing, NAT translation, application layer gateway, other services. And then it's going to be sent to its destination interface, which in our case is an interface associated with the trust zone, okay? And there's some other things that go on here, a filter packet, a shape packet. Ultimately, though, we're getting to our destination. So this is an important thing because we have to understand what the SRX does to the packet. And part of our responsibility in configuring this security gateway are all of these different steps. Okay, all of these things that we see are going to be part of the purview. They're going to be part of the responsibility that we have in managing this SRX device. So we kind of have to look under the hood and know what's going on. So I want you to return to this flow chart from time to time, and especially come back to it at the end of the course because it'll make so much more sense to you as we look at all these other services. Okay, excellent. Now, I do want to say this, even though initially we're going to be concerned with configuring the trust zone and the untrusted zone, if you have done good planning and if you've thought ahead and if you've done a lot of information gathering for your branch office, your remote office, then you know that you're probably going to have other zones as well. So we want to know this usually ahead of time. Even if it's not in our original configuration, or our basic day one configuration, we do want to know ultimately what zones we're going to have and what interfaces we're going to assign to those zones and the policy, okay? So the way the traffic flows between zones or inter-zone policies. So we might have a DMZ zone. These would be public servers that are being accessed by users on the internet, okay? So users that are initiating sessions on the untrust zone to servers that we're providing here. You may have a guest zone. You may have a partner zone. These are people that are coming to your office, your branch office, and they're using a laptop, for example, and they want to plug in a foyer or a conference room. You might want to put those interfaces on that switch connecting to one of these zones. And also, you may want to think about, in a small to medium-sized business, creating zones for different departments, like maybe an accounting zone. And you want to think about, well, what type of broadcast traffic is being generated in that zone, and do we need a policy to protect traffic between that zone and just the corporate LAN, right? Because maybe they're dealing with, financially sensitive information. Maybe the HR department needs its own zone. Maybe you have an R&D department that has to have its own zone. Maybe you have a call center, okay? If you have a call center at this regional office, let's say, then most likely the call center will be in its own zone. Anytime you want to prevent a fire from spreading from one area to another, and you want to protect resources in one zone to another, you're probably going to create additional zones. Okay, now you have to think about your particular device, and do you have enough port density on that device for all the zones? If you don't, then that means going up to a more robust platform. Usually at the branch office, you're not going to have more than maybe 4 or 5 zones tops, okay? But we want to think about that before we start diving into the configuration. Okay, now, our zone is just a logical container that we create in software. We're going to see that. It's just a container that we apply policy to, and then we associate interfaces to that. However, interfaces are not, okay? Those are real things. We're staring at them right now. And there's some interesting interface behavior on a Juniper SRX that we have to talk about. Now, the first thing I want to establish is this. In the earlier diagram, we saw that there was traffic that was ingress, okay, ingress traffic on an interface, right? Okay, that's fine, but what kind of traffic, okay? Traffic that's destined to that interface right there, FAST00 or FE00, can be 3 types. What are they? Well, the first type would be, I'd say, over 80 to 85% of your traffic, and that's user data traffic. Okay, obviously this is a packet that is coming ingress on this interface, will ultimately be switched and routed egress out some other interface to get to a server or a host. So it's data plane traffic, right? We also call it transit traffic or transient traffic, and frankly, that's most of your traffic. We could also refer to this as inter-zone traffic, okay, traffic going between one zone and another. In this case, the untrust zone to the trust zone, for example. Then there's management traffic. We call this system services traffic. This could be things like a ping or trace route or secure shell, things that are actually used to manage this device. And what's interesting about management traffic is the destination IP address will actually be an IP address of this SRX. Okay? With user data transit traffic, the destination IP address is going to be some host on one of these other interfaces in another zone. With management traffic, the destination IP address will be assigned to this device itself. And then there's protocol traffic. So we call it simply protocol or protocol-related traffic. That could be OSPF advertisements or other dynamic routing updates. It could be DHCP traffic because this device is a DHCP client, for example, of your service provider. And again, protocol traffic, like management traffic, the destination IP address will be this device itself. And that's one of the main things that separates management and protocol traffic from the user data transient traffic. Now, things get kind of tricky once we start looking at traffic destined to an interface with the goal of device management. This brings up a term called host inbound traffic. So here's a very important fact. I'm going to put it in the form of an axiom, okay? Management traffic doesn't traverse the SRX. It terminates at the firewall itself. Therefore, this traffic does not get examined by any security policy. Put that one in the bank. Now, host inbound traffic is just what it says. It is traffic inbound to this host for the purposes of management. But what's kind of tricky is you can actually configure host inbound traffic at two different levels, the zone level and the interface level. Okay, well at the zone level, if you do configure our system services, then they're going to affect every interface that's bound to that zone. Yeah, that's right. You can have multiple interfaces bound to a zone. 2 interfaces, 3 interfaces. That's a huge difference, by the way, of that old school classic firewall. Now with the zone-based firewall, we can create a policy, we can apply the policy to a zone, and we can put multiple interfaces in that zone, and that all those interfaces will have that policy. Okay, so you can configure this host inbound traffic at the zone level, but you can also do it at the interface level. But here's the deal. If you configure it at the interface level, for example, FE00 here that we're looking at, it only affects that specific interface. So, what happens if you have host inbound traffic on FE00 and that host inbound traffic policy is configured at the zone level, because it's a member of a zone, and you've got something applied to it at the interface level? Well, listen carefully, and this is test worthy. The interface settings always take precedence. In other words, the zone services won't apply. So let's say you configure, I don't know, ping. That's a management system service. If you configure ping at the zone level, and let's say that you've got FE00 and FE01 that are going to be part of the same zone. How about the untrust zone? Is it a good idea to have multiple links going to your upstream customer edge router or to your service provider? You bet it is. So what if we have a ping system service policy at the zone level, the untrust zone, and both of those interfaces are attached to that zone? If you try to ping that interface, FE00, FE01, you'll get an echo reply. But later on, let's say you enable telnet just on the interface level for FE00. If you configure that system service at the interface level, then on FE00, the ping will stop responding. Why? Because once you apply interface settings, they take precedence and they override anything you did at the zone. So what would you have to do? Well, you have to configure, if you're going to go at the interface level, you have to configure telnet and ping services at the interface level on fast E00. This is important because this is just the kind of troubleshooting stuff you're going to run into right off the bat. Because, hey, you're going to have ping services. Those are foundational. Now, keep in mind that this host inbound traffic, okay, these settings, these service settings that I'm talking about here, they have no effect over the outbound traffic, traffic that's coming out of FE00 and FE01. Now, before I dive into the CLI, there's something I wanted to talk about just real quickly. And in the JNCIA, I talked about this, the routing tables, the routing instances. Whether you know this or not, there are several instances, okay? We know that the IPv4 routing table is inet.0. You've also got an IPv6 routing table. You can also create your own instances on the enterprise level. One thing I want you to know though, when we go up here and look at this route lookup and this forwarding lookup here, we're using the routing table, right? So by default, this is important, all of our predefined zones, and we know that the trust zone and the untrust zone are the predefined zones we've talked about, or if you create your own zone, so for example, if we create a DMZ zone, it's going to be bound to or connected to the routing instance of INET 0, okay? And that is the IPv4 routing table. Unless you configure it otherwise, that's the default behavior. So that's what we're looking up here. So when we go down here and we configure IP addresses on these interfaces, and then we bind these interfaces to a zone, it's going to generate a host routing entry table in inet.0. Okay, let's go jump over into the CLI and cover some basics as you wrap up this nugget. Now, I want to tell you this real quick. I'm going to take a different approach in this JNCIS security nugget than I've actually taken in the last couple of nuggets that I've done. For example, I just finished up the healthcare IT technician CompTIA one, and then before that I did JNCIA, and some of those nuggets got pretty long. You know, some of them were 50 minutes, some of them were over an hour. I kind of want to get back to the CBT Nuggets tradition in this series of doing nuggets that are, well, they're more like nuggets, okay? They're about 35 minutes long. So that means that this JNCIS security series will probably have ultimately a lot more nuggets in it, okay? Well over 20 nuggets, because I'm not going to do these hour-long sessions. I really think these small 35-minute chunks are the best way to tackle security on the Juniper SRX. So that's the way I'm going to do it. So we're going to go look at the CLI here, a few things I want to show you, and then we're going to wrap this one up. I want to get back into the CLI here as we finish up, because I want to make sure that we know where things are, okay, and how we can show things before we start getting into the next nugget, which is going to start out with the factory default configuration, which we've definitely got to know that. So a couple of things. We configure our interfaces as we know. We have to get into, the configuration mode. And let's see, okay, it's been changed, not committed, that's fine. Okay, so I'm in configuration mode. If I want to look at my interfaces, it's edit interfaces, hit the tab key, and now I'm in edit interfaces mode. We can do a question mark here, and okay, there's my commands. That's kind of a problem. Let me do something else. Let's go ahead and just do a control C. If I want to do a show command here, or even help, and I don't want to see the more, like it's showing me there's more, 82%, I can do a show with a pipe symbol and then issue the command no more. And then that way it just shows me everything and I can just scroll up, okay? So obviously this is the mode we see our interfaces. I've got 8 interfaces on this. This is a 100. We'll be looking at a 210 later on. So I'm kind of working my way up. And we'll need both. I'm going to need both devices because when we do our IPsec VPN, we're going to create the VPN between those two devices. And there's some differences in the 210 that are important for the exam as well. And it's probably pretty likely you'll be using that one. Like I said though, all you need to do to get your hands on a device, the 100 is just fine. Don't go spend any money on the 210. What I'm going to show you, or anything higher. If you have access to something higher, awesome, okay? But don't waste any money. You don't need it for this exam, not at this level. Okay, so you can see I have 8 interfaces. There's FE0 all the way down through FE7, okay? They're all fast Ethernet. Now on the 210, when we get to that one, that'll have, the first interface will be gigabit, okay? So it's got 1 gigabit Ethernet interface, which is typically going to be your untrust zone. It goes to your service provider. So we can see a couple things here. There's some VLAN. These are all family Ethernet switching. They're by default in a VLAN called VLAN Trust. And one thing about VLANs in Junos is there's no native VLAN like Cisco has. You know, they have their native VLAN, which is VLAN 1, which are untagged packets. We don't have that in Juniper, and trust me, that's a great thing. So if I want to, let's say, look at zones, or maybe remember the host inbound traffic I talked about? Where do we configure those? Well, that's in a whole different area of the hierarchy, but I can get there in one command. Okay, so I'll issue the top, which means go to the top of the hierarchy and then type in edit security zones. And now I've gone to the top of the hierarchy and then right back down into this area where I can see edit security zones. I can do a show command here. And we can see this is what we're going to start getting into when we get into the default factory configuration in the next nugget. I'm just showing you how to get around right now to remind you. So we can see here's our host inbound traffic, okay, and we talked about system services, right? So that's pretty cool, and we'll break that down even more. We'll be talking about screens as well. This is really our countermeasure against flooding attacks and denial of service attacks. It's what we call threat mitigation. We'll get into that. Okay, what about policies? Okay, one thing that's important is I've talked about how we create zones and we assign policies to zones, right? Well, we don't configure our security policy under this edit security zone hierarchy, okay? We create our security policies and edit our security policies by basically going to that particular area. So we'll say go to the top, edit security policies. So here we are in our security policies area. Do a show command there. Not a whole lot going on, right? Just the trust zone and the untrust zone. But let me just reiterate, we configure our policies under edit security policies, not under edit security zones. Very important. You may need to know that on the exam. Wink. System services, okay? And by the way, I've talked about system services and the host inbound traffic. Well, let's go there real quick. Top, edit, system services. And we'll do a show command here. Obviously, we're going to be breaking this down, but we can see some things here, right? We see secure shell, we see telnet, we see web management, HTTP, HTTPS, DHCP, right? These are all the types of things we're talking about. This is not data plane or transit traffic here. So remember, just going and configuring the system services host inbound traffic that I showed you earlier, like for example, I mentioned ping or telnet. That's not enough. If you're going to manage your device through interface FAST001, for example, just doing interface system services is not adequate. We're going to come to this area right here, and I have a dedicated nugget on this, by the way, coming up. Edit system services, and we're going to configure things like telnet, secure shell, FTP, our JWeb access, for example, using HTTPS. So this is the area we're going to come to do that, not just going to an interface and configuring some system services individually. Not good enough at the enterprise level. Now, by the way, if you want to see the factory default configuration, you can do a couple of show commands, okay? So there's some show commands that we probably want to do some question marks on. Or I could have done run show configuration question mark. Okay, some of the commands we're going to focus on here, and there's a lot of them, but show configuration interfaces. Okay, that's a big one that we're going to use to examine the factory default configuration. There's show interface terse. I showed you that in the previous nugget. We'll also do show, let's go down to security, show security zones details. That's a good one. There's also show security NAT. So there's several under show security we're going to be using. There's show configuration system services. So here's services here. And show configuration. I think that's pretty good. So basically, show configuration has several subcommands that we can get more granular with. And of course, I did the run here so I could see this. This is typically an operational mode command, but I'm in configuration mode. Now I can just do a basic show configuration and I'll see everything. I could have done no more as well, which may not have been a bad thing to do. Here I have to use the space bar and kind of go through everything. So this is the factory default configuration. So what we're going to do first thing in the next nugget is we're going to come in here and we're going to talk about some of the most important aspects of the factory default. It's the things especially that we understand up to this point, okay? We haven't got to network address translation yet. We haven't got to screens. We haven't even gotten to policies yet. But we need to start building this foundation and moving systematically and methodically through our SRX knowledge. Very cool. All right, well, in this CBT Nugget, we actually covered quite a few topics. We started out looking at the differences between the classic firewall versus the zone-based firewall, kind of moving away from all those access control lists and rules and inspection rules to a more modular, logical, scalable view. We defined security zones, looked at some sample topologies, some of our possibilities for the branch, for example, introduce that packet flow. You'll be returning to that throughout this Nugget series. We talked about some SRX interface essentials and then finished up with a quick review of some important edit and show commands that we'll need as we progress farther through this Nugget series. Well, I hope this CBT Nugget has been informative for you. I want to thank you for viewing.